Hi there, in this video I'm going to do a past exam question on logarithms. So let's take a look at this question. Question 5a. Find the positive value of x such that log of 64 to the base of x is equal to 2. So let's see how this can be done. Let's go back to the paper and pen. Now to do this problem we need to use this result. So let me go through this result. So if log of b to the base of a is equal to c, so in any equation of this type we would regard this as being in logarithmic form. Now we can use this result that I'm going to complete in order to write an expression in logarithmic form into index form. So if you have log of b to the base a equals c, we can write that as b equals a to the power c. So this expression on the right we would regard as being in index form. So this relation goes both ways. You can write expressions from logarithmic to index or from index to logarithmic. Now this very question that we have, this very equation, this equation is in logarithmic form. So let's figure out what a, b and c are, and knowing a, b and c we can write this given equation in index form. So by comparison, the a term is x, so let's make a note that a is x. How about the b term? The b term is 64, so b is 64. How about the c term? The c term by comparison is 2. So c is 2. So to get a, b and c, since your equation in question is in logarithmic form, compare the two parts which are in logarithmic form in order to understand what a, b and c are. So we've noted a, b and c terms. Let's replace a, b and c then in the index form of the relation. So b is 64, so I'll write 64, that is equal to a being x, to the power of c is 2. So let's reverse this to give us x squared is equal to 64, and x therefore will be plus or minus the square root of 64, which is plus or minus 8. Now if we go back to the question did say find the positive value of x. So going back to the paper and pen, so let's complete this answer. So let's just say that x is plus 8 because we're taking the positive value. So that completes the first part A of this question. Now let's go to part B. Now we need to solve for x, and we need to solve for x the equation log of 11 minus 6x to the base of 2, and that is equal to 2 log x minus 1 to the base of 2 plus 3. So let's see how this can be done. Let's go back to the paper and pen. So this is the equation that we need to solve. Now we need to use laws of logarithms in order to help us with this equation. First of all, what I'm going to do is I'm going to take this term here, and let's bring it to the left hand side to give us log of 11 minus 6x to the base of 2. And if I take this term to the left also, so minus 2 log of x minus 1 to the base of 2, that is equal to 3. Now I'm going to use the power law of logarithms to make this 2 a power. So let's use the power law. So remember the power law of logarithms. If you have log of b to the power of n to the base of a, that's the same as writing n log b to the base of a. So I'm going to go backwards from here. So I'm going to make n the power. So I'm going to go backwards from here and apply it to this term here. So let's write this equation as a result as log of 11 minus 6x to the base of 2, making this a power. So I'll have minus, so minus log of x minus 1 to the power of 2 to the base of 2, that is equal to 3. Now, why did I do that? I did that because I can use another law of logarithms to rewrite the left-hand term. So the law that I'm referring to is this. So the law is, if I have log of b to the base of a minus log of c to the base of a, that is the same as writing log of b over c to the base of a. So since the bases of my logarithm functions are the same, I can apply this law. More specifically, the coefficients are 1s, just as what I have over here. That is the reason why I brought 2 and made that a power using the power law. So I use the power law so that I can use this law quite easily to simplify the left-hand term. So let's apply the law. So according to this, I can rewrite the left as log of 11 minus 6x, let me take a ruler, divided by the x minus 1 squared to the base of 2, which is equal to 3 on the right. And in order to solve this, we can use this relation, the relation that we used before. So remember, if b is a to the c, then c is log of b to the base of a. Let me show you how to apply this relation to help us solve this equation. So let me write the relation again. So b a to the c, that means c is log of b to the base of a. So if I go back to this relation, if I compare this, so let me recopy this so that we can see it clearly. So I have log of 11 minus 6x over x minus 1 squared to the base of 2 is equal to 3. So let me recopy this. So log of 11 minus 6x over x minus 1 squared to the base of 2 is equal to 3. Now, let me show you how to use this law to take it one stage further. Now, this equation is in logarithmic form, so let's work out a, b and c so I can rewrite this in index form. So if I compare this in logarithmic form to the logarithmic form of the relation, we can notice that the a value is 2, so a is 2. Let me take another colour. For the b term, b is this term. So our b term, let's make a note, is 11 minus 6x, all divided by the x minus 1 squared. And how about the c term? The c term by comparison is 3. So now that I know a, b and c, let's replace it into the index form of the relation. To give us b is this term, so b is 11 minus 6x, let's keep that in a bracket, divided by x minus 1 squared. That is equal to a is 2, to the power of c is 3. Now we know 2 to the power 3 is 8, so we have this equation to solve, and this equation is quite straightforward, so we can cross multiply. So if I cross multiply this equation, 8 times x minus 1 squared is 8 into x minus 1 squared. That is equal to 11 minus 6x times 1, that is 11 minus 6x. So let me expand this bracket here to give me 8. Expansion of this term will give me x squared minus 2x plus 1. that is equal to the 11 minus 6x on the opposite side rather. Let me get rid of the brackets. 8 times x squared is 8x squared. 8 times minus 2x is minus 16x. 8 times plus 1 is plus 8. That is equal to 11 minus 6x on the opposite side. Now the idea is to make a quadratic equation. So if I take these two terms on the right to the left hand side, I'm going to have 8x squared as a result. Minus 16x plus 6x is minus 10x. And 8 minus 11 is minus 3, which is equal to 0. So I have a quadratic to solve. Now we can factorise. This quadratic is factorisable, or you can use the formula. So I'm choosing to factorise. If you were to factorise, the factors are 4x plus 1 and 2x minus 3. And as a result of the factors, we have two values of x. So either 4x plus 1 is equal to 0. So when I rearrange, one of the x's is minus 1 over 4, minus a quarter. Or 2x minus 3 is equal to 0. And when I rearrange that, the x value is 3 over 2. So that completes the part, and that completes this question. So I hope you enjoyed this video. I hope you found this video helpful. If you did enjoy the video, a like rating is very much appreciated. Now, if you're unaware of the concepts used to solve these examples, I have created videos explaining the concepts, and I'll provide links to those videos in the description below. Other than that, I hope to see you again. Thank you.